Here we go, session 15. I think we've got two more on calculus and differentiation. So we've got this one and then one more after this. And then that's another chapter done. So let's get straight in. Okay, so we're going to start with increasing and decreasing functions. And then we're going to move on to the second derivative, which is quite quick at the end. And I think what I mean by an increasing function is when the gradient, so increasing function is when the gradient is greater than 0. Okay, so an increasing function is when the gradient is greater than 0. So it's when dy dx, because remember dy dx just means the gradient, dy dx is greater than 0. This is an increasing function. And decreasing is just when dy dx is less than 0. We say that's a decreasing function. Now in a future session we'll see when dy dx is equal to 0, that is what we call a stationary point. We're going to do that next session. Right, okay. I think it's worth going straight into an example with these. So e.g., work out the values of x for which y equals x squared minus 4x plus 1 is an increasing function. Okay, classic sort of exam question that, probably a 3 or 4 marker. Work out the value of x for which y equals x squared minus 4x plus 1. So it's an increasing function. So I know it is when dy dx is greater than 0. So I need to work out dy dx. Dy dx I need to differentiate y. X squared becomes 2x. Minus 4x becomes minus 4. The plus 1 disappears. So dy dx is equal to that. So therefore 2x dy dx is greater than 0. I solve that inequality. 2x is greater than 4, x is greater than 2. That would be my answer. Okay, I can see this on Desmos. If I go y equals x squared plus minus 4x plus 1. X is 2. Okay, anything to the right, anything in this area here, that is a positive gradient. So that's absolutely right. Anything bigger than 2, the gradient of that curve would be positive. So that's how we do those questions. Right, straight in with some examples then for you, or some practice. Exercise 8D, which is on page 222. I just want you to do questions 3, 5, 7, and 9. Okay, 3, 5, 7, and 9. Off you go. Right, do pause the video while you're doing that, but once you have finished, you can then put another sort of subtitle as the second derivative. And again, second derivative, and this is known as d 2y over dy squared. This just means you differentiate twice. Okay, you differentiate twice. It is not, this is an important thing to note, it is not dy dx squared. Okay, that is a really important thing to note. And we'll see in next session there are some uses of the second derivative. So we'll see what the point of this is. Remember, dy dx tells you the gradient. The second derivative tells you the rate of change of that gradient. So you can use it to work out stationary points and whether they're maximum or a minimum. We'll come to that later on. Again, best to do an example. So y equals 2x cubed squared plus 3x plus 1. Find d2y over dx squared. That could be the question. Find the second derivative. This is known as the second derivative. Okay, how you'd answer this, you need to find, first of all, first derivative, dy dx. So dy dx, should be good at these now, 6x squared, that's going to be minus 8x plus 3. And then I differentiate that again. So the second derivative is going to be 12x minus 8, the 3 disappears, and that would be my solution. Okay, bit more practice for you to do on that. So page 225 this time, which is exercise 8E, and can you do questions 4, 6, and 7? Okay, so not a super long session today, but please take your time to answer those questions carefully, and we're going to continue with the last session on calculus next time. So see you then.